Hello everyone, this is Jacob Hobio, the producer of The Apex. In this episode, Jan and RJ interview Dr. Jean-Philippe Burckert. JP has his Ph.D. in bioinformatics and computational immunology. His Ph.D. work was presented in over 20 international conferences. After academia, JP joined the bioinformatics consulting firm BISC Global as a Senior Bioinformatics Consultant, where he helped to establish the new department in Boston, Massachusetts. JP is now the head of computational and informatics efforts at Centivax and leads an amazing team of scientists and informaticists. Check out Distributed Bio here at www.distributedbio.com. Look at the newest initiative, including COVID-19 research, here at www.centivax.com. If you want to support us, there are 3 ways to do so. One is to donate to our cause at www.patreon.com/theapexpodcast. Second, visit our merch line that is proudly partnered with Envision Clothing Company at envisionclothingcompany.com. The final one is completely free. All we ask is if you learn something from this episode or know someone that needs to hear our message, share it with them. Please subscribe and hope this pushes you toward your apex.
Welcome, Apex Chasers, to another episode of the Apex Podcast. As always, I am your host, Jan Almasi, and seated across the county from me is my co-host and partner in crime in self-quarantine because of a global pandemic, Mr. R.J. Holiday.
How's it going, everybody? Hope everybody's been well. Hope everybody's taking care of themselves and the people around them. It's good to be back on the interwebs.
Yeah. I just realized that out of all the times that we've recorded on Squadcast, you're the only one that never shows himself on camera.
I'm waiting for the 1 million viewer face reveal. No, no, the house is a mess, and I'd rather spare our listenership what the back of my computer/gaming station looks like. So we'll keep that a secret until I get a gaming lab that looks pristine.
Alrighty. Well, so today we're actually interviewing somebody that is currently, I assumed that they were just in Belgium, but apparently they're currently stuck in Belgium from what I understand. And this is another individual that is a member of the Distributed Bio team. As we've kind of caught on, we've kind of been going through the Distributed Bio team one by one.
Down the line.
And trying to chronicle the life stories of the army of super geniuses that Mr. Jacob Glanville has assembled, as he so fondly refers to them as the Avengers of science. Unfortunately, I do not have the copyright to the Marvel theme song, so we can't use that to intro them. However, there is an email sitting in their inbox. So
they do need all to have superhero aliases. They got Snake Man.
Yeah, and we got a whole bunch of different personalities that are. I truly mean that they are beyond an intelligent group of humans. So today we're going to be interviewing the Director of Informatics and Immunoengineering, if I remember correctly, and he can correct me once we kind of bring him on. But I'm going to give the last name a good shot. We practiced this a couple of times before we came on the show, but everybody please welcome Mr. J.P. Burckert.
Thanks for having me on.
Close.
So the name is complicated, and I've suffered from this the moment I set foot on the USA. The first name JP is a shorting for Jean-Philippe, which breaks the average American tongue, and then the last name, a German name, Burckert, it's just too much. So I usually just go by JP, and that just works fantastic.
That's why I go by RJ. There's too many people get confused.
What does RJ stand for?
Robert James, a little bit easier.
Everybody just assumes that I'm like a 50-year-old woman anytime I introduce myself because they think it's Jan.
Hi, I'm Jan.
Yeah, and then they get surprised when a 24-year-old male walks into their room as their ICU nurse. I'm like, hi, my name's Jan. Looks like Jan, but it's pronounced like you're about to fall asleep. And then I kind of get a little bit of a giggle. They're like, oh, like you're yawning. I'm like, there you go. Now you get it. So. JP, why don't we just start as we kind of, people have come to expect from the Apex. We'll just start kind of where you were born, where you grew up.
All right. I was born in Kaiserslautern. It's a a small town, about 100,000 people over there in the south middle of Germany. There's a U.S. military bases attached to it called Rammstein, like the band. And that's where I was born, grew up until I was 6 there. And then my dad got transferred to another site at his work, and that was Saarbrücken, which is another small town. About 200,000 people living there at the border to France. And that is where I grew up, basically, and spent most of my time.
So you were born right next to Rammstein Air Force Base, right? And then, so that transition, you said your father moved because of a job?
Yeah, exactly. He was working at the University of Kaiserslautern, where he was part of a new informatics institute that was coming up, the DFKI GmbH, which stands for Deutsches Forschungszentrum für Künstliche Intelligenz. It's a German research center for artificial intelligence. Back in the days, when AI was still something that people didn't know about, and it was something more connected to mathematics than the actual informatics field. And he was part of that. And then they had another site coming up in Saarbrücken, and they transferred him over there. So that's how we got moved over to Saarbrücken.
So for time reference, what time period is this? Because I think that the perception for the general public is that artificial intelligence is a new thing and that it hasn't been in development for as long of a period of time as people think. But so what time period was that move?
Yeah, I think ever since people have been using computers from the early days on, they've been thinking about how we can make this thing do our thinking, right? How we can make a computer be like a human. And the time frame precisely, I mean, I'm born 86. So in the early years, that was around the 80s, mid 80s, beginning of 90s, when my father was getting involved into that. I think he achieved his Ph.D. in 1990 in artificial intelligence.
Wow. And that's what I like I said, I think that people underestimate how long we've been trying to get computers to do our thinking for us.
I mean, I would say most people would be hard pressed to believe that somebody in 1990 got a PhD in artificial intelligence. Because
that's absolutely true.
You don't go to your average college and go, oh, here's exercise science and dietetics and artificial intelligence. I'd like to take those courses.
Yeah, and my father has actually written a piece about that recently in one of the artificial intelligence news magazines, where they talk about this, that where they come from originally, this was kind of not really seen as a science subject, right? It like started from the informatics field, from the mathematics field, sorry. And then like within the mathematics, all these computer nerds were frowned upon. And it was like a research area that didn't receive very much attention. Actually, interestingly, while in the US, it was already booming and there was like a lot going on, but Germany in particular was sort of lagging behind a good bunch. And my dad was at the forefront of this changing and becoming an actual thing that you could study and receiving the respect that it truly deserves, and making it into this fantastic field that we have now. That's
awesome. To be there like right when it's breaking within your country and be one of the smartest minds in that field, to be like, okay, you guys can go ahead and stop looking down on what we're doing over here, because obviously it's a little bit more important than what you thought it was going to be.
Yeah, it was a lot of politics and lobbying, at universities, talking to the big old guys that were running mathematics since 30, 40 years. And now you want to tell them, hey, there's actually a new thing coming around. You better pay attention to it. Everyone around the world is doing it. And as it goes with universities, they're kind of slow moving and it takes some time until they take this up. But then, it got established, and now it's one of the biggest, if not the biggest, research field out there.
Wow.
So have you always known that you would be interested in some type of mathematics, informatics field? Because you are an interesting mixture as far as the fields of study that you chose to study along your path, right? So could you pinpoint like a time that you kind of really started to realize that this is something that you would be extremely interested in pursuing?
Mm-hmm. So go ahead, Reggie.
I just wanted to say, I guess for the general public, what is informatics? I guess for someone who isn't savvy to what that is exactly. Because you compare it closely to mathematics, and that might confuse some people, because math is pretty straightforward.
Oh, sorry. Yeah, that's what I thought. So the field of informatics is, and we can do probably like an entire series of podcasts just about that, right? The field of informatics is, I think, roughly defined as applying mathematical algorithms and logic using computational systems to solve problems, like in a very, very rough definition. And my brother, who is also an informaticist, is probably shaking his head right now. A lot in informatics, and I followed him through the course of his studies. A lot in informatics is mathematically based. It's a lot of logic, logic operations, and those then translated into computer language, so to say.
Gotcha.
That is how that comes along.
Gotcha. All right, back to Jan's question.
All right, can you quickly repeat?
No, just pinpointing a period in time that you really realize that this is something that you would be interested in pursuing for your career.
Gotcha. So interestingly, I've always seen myself like chasing science around the fields, because there's no particularly like subject that I'm interested in. I've always seen that science is an interconnected piece. Like that, right now I'm applying informatics to immunological problems, right? And this is this fantastic time that we're living in right now, where we have so much access to all the kind of information around us through the internet, right? I can look up right now what a coronavirus is, and we will be talking later about that, and can like soak up all the information that is out there. And this kind of interconnection is really the basis of my work, that there's so many different subjects that go together. And I've done that throughout the course of my life, that I started with a subject, and then I realized there's more to it, and then I venture into a new subject, into a new field, and that is ultimately how I ended up in computational immunology. And maybe that's not even my endpoint. Maybe there's something else coming around. And if you want to like pinpoint that a little bit, where this all started, I think this was connected to being in a household where science was all around us. I remember my dad coming home, and he had a couple of different scientific literature laying around at home all the time. There's a couple of German news magazines where you can see the latest and greatest things in science across all different fields, whether it's chemistry, physics, informatics, biology, medicine. It's all in there. And he was reading that with great interest, just to like get knowledge about what's going on. And that is what science for me in the end really is. It's distilling knowledge out of like things that we don't comprehend, that we don't understand. Like, how can we get to the point where we say, oh, I know this now, and then can I use this to make like the world better or change things? That is basically my take on science. So there's no singular point that I say, okay, this was the point where I was interested in informatics. It sort of gradually grew just by being exposed to it all the time.
Right. And being interested in problem solving. I think that's kind of like a root. I've really noticed that, even between my team members, but then especially like between all of the distributed bio team members, all the way from, 17 years old to, 30s, 40s, all of everybody that's involved with that has a deep rooted desire to, like Glanville always kind of says, solve tomorrow's problems, and kind of predicting, hey, where is this technology going? How can we use it to advance the cause, not just for today or solving problems of the past, but also projecting forward and saying, this is what we're predicting is going to happen. Let's solve it before it happens. Which is what I think is absolutely amazing about specifically DBio as a company, is just that type of projected forward thinking. And that's kind of what we're trying to do right now with this whole radical transparency, is basically putting people out and saying, hey, like you said, you can get online and look at all of this different information, compile it, and then use that to your advantage. There's this exponential wealth of information in the world today. So since there was no really singular point, you got your first chemistry tool set when you were 12 years old. Why don't we talk about what that was like?
Yeah. So like ever since I was a child, there was, as I told you, like many things that like piqued my interest. And I was very, very close with my grandfather from my mother's side, who was a self-taught chemist. at Siemens in Germany. So after the war, he had no real like education as such, because there was just no money and no time to like go through the standard procedure that we have now, like going through high school and then maybe to university. So he taught himself chemistry because he was excited about it, and he got a job as an analytical chemist at Siemens, and then went on like leading this entire department. And he got like saw my interest in chemistry, and I think when I was around 12, 13 years old, he got me a toolbox, like Cosmos Chemistry 1000 or something like this it's called. And there's like a bunch of different substances in there, and you can mix together, and you see how the substances change in physical appearance. Like they change color, they heat up, they cool down. And he spiked that with a lot of information and knowledge he had from his work. And we had regular like sessions where we came together and we're just cooking up stuff. And it was like, for me, super exciting to do all that and to see that this is possible. But at the same time, he said, you got to know what you're doing. So you need to keep documentation. You're going to take a little piece of paper or like a little booklet, and you're going to write in it. And you're going to write what you want to do. You're going to write what you observe and then what your conclusions are from this. And ever since, like I studied chemistry later and other scientific subjects, this has always been the approach. You always think about what do you actually want to do. And then you write down what you observe. And then you draw conclusions based on your observations. That goes through all the different fields in science.
Oh, yeah, for sure. I mean, and even in kind of like the marketing communications arena and this other kind of stuff, that's the basics of an A/B ad test. You're projecting this is how the audience is going to respond. You observe how they actually respond, draw your conclusion, and then readjust. I mean, the scientific method, I think, is something that people underestimate as far as its applicability across, like you said, all different fields. That the ability to logically problem solve and document your process is invaluable across all the different arenas of study. So you got your first chemistry set at 12 years old, and then obviously that continued to grow into a deeper interest, and you ended up studying chemistry for your undergrad, correct? And
yes.
And then kind of pursued an additional degrees beyond that. So what did that pathway look like after getting your chemistry degree in undergrad? How did you decide what you wanted to go into next?
So, I mean, that event with my grandfather in that time sparked my interest in like studying chemistry further and see what else you can do with it. So I went to university after high school and enrolled into the standard chemistry course that we had, actually in Kaiserslautern. So I went back to the roots where I was born, to that university there. And the University of Kaiserslautern was still using the old German diploma system, it's called. So that's a straight master. You start there and you study for 5+ years and you get your master at the end. And there's no like bachelor's degree in the middle or something. And the great thing about Kaiserslautern in that regard is that you study the basics up until a certain point where they make you choose a specialization. And in chemistry, that basically means you can specialize on whatever you want, because it's a very, very broad subject in the beginning. Like, they teach you all the basics of mathematics, about physics, and chemistry, obviously. And then you can like put your specialization on top of it. And my specialization that I chose, because I was most interested by it, was the life sciences. So during my studies, I learned all this other stuff: chemical analytics, theoretical chemistry, organic chemistry. And I saw a lot of these things being, maybe a lot of people will roll their eyes now when I say that, but I see a lot of these things being replaced largely by robotic facilities. If you want to do organic synthesis, it's so much easier to do that with a massive robot facility that just tests so many different varieties and compounds. And now that I went into the informatics field, I've seen even people applying AI to it. So I didn't see an interesting job perspective for me there. And I thought, okay, where can I go where this gets more exciting? And one part was the life sciences. So I went on studying biochemistry, biotechnology, pharmacology for about 2 years. And one of the most exciting subjects I came across in that time was naturally active compounds. So you hear this a lot that our antibiotics are like largely plant-based, right? you have a certain, or bacteria based, you have a certain bacterium that you dig out of the soil, and this bacterium produces a substance that keeps all the other bacteria at bay. And that's your antibiotic, right? So if you find a way how to extract that substance out of that bacteria, make it safe for humans and manufacture it, you got an antibiotic. And that fascinated me. And back in these days, I've read about a group that was researching these things in sponges, in marine sponges, so that because they can't run away. It's actually very, very fascinating. So if you have a marine sponge that is under constant attack by other organisms around it, a lot of them are microscopic, so bacteria, and he can't run away, right? There's no way for the sponge to escape because it's fixed at the position that it's sitting at. So the sponge has to have a lot of capabilities how to fight off these invaders or pathogens. And so there's an entire group or entire field evolving around marine biotechnology, how you can harvest antibiotics and substances that are produced by these sponges and use them as medical devices for humans. So that got me into this field. And ultimately, you have to, in Kaiserslautern, you have to do a master's study. So it's about a 1 year that you enroll at an institute or at the university in a research group, and you conduct your study, and then write a thesis about it, and then you graduate. That's the process there. And because of that interest that I had in this drug discovery procedures, I went to do that at the Institute for Biotechnology and Drug Research, I think it's called in English. And there we were working on fungi that kill wine plants, like grape wine plants. That is it's an entire field of subject, a study field as well that I never heard about before, but I found it extremely fascinating. It's a group of 4 different, or probably even more, different fungi that work together to destroy wine plants, grape wine plants, and it's drastic. If you have that in your vineyard, it's going to destroy the entire vineyard, and there's nothing you can do. At least at the moment that I studied, nothing you can do about it. The only way they could treat it in the past was by injecting sodium arsenite into the wine plants. And obviously, you don't want to have that in your wine, right?
Absolutely not.
No. And I don't know anymore the exact time point when it was banned in the EU, but it was shockingly recent. It was
later
100
than
years.
expected.
Yeah, you still have wine out there that you can buy that has wine plants being treated with sodium arsenite potentially. So they were looking on a kind of cure, right? Something that you can use to fight off these ESCA diseases, as they are called. My work was involved in figuring out what makes these fungi tick, how they work, how they invade the plant, and how they sit there and destroy the plant from within. And I did some 1 year research on that.
I find it really interesting that you noticed that curve of robotic assistance, or full, I guess, takeover of those fields, possibly sooner or in the future than I guess probably most people would think about when they're thinking of choosing a major. Because it's true, like what you said, the advancements in AI and even just the capabilities of the robotics, they don't get tired, they don't need fed. They work endlessly around the clock, whether you're there or not. It's hard to sit there and be like, okay, well, in 10, 15 years, I'm choosing to do this concentration in this field, and there may not even be a job for me there.
Yeah. And I mean, ultimately, I think there will always be people involved to a certain stage, but this general hands on deck, right, that kind of work will be constantly evolving more towards a robotic facility. I've seen people in the lab that were running 32 reactions at the same time in a kind of little reactor block that they designed and came up with in Kaiserslautern. And I was asking a question, why don't you let a robot do that? Why is this poor student sitting 14 hours in the lab 7 days a week, to tender to his reactions that can be monitored with a computer? And, injections of certain substances at certain time points, you can all automate that. You don't need somebody to stand there and look at it.
And it can be so precise, to the point where human accuracy is only so great.
Exactly. And you couldn't run just 32 reactions, but 32,000 reactions.
Yeah, exactly.
Scale this thing up, build a big facility, and do it properly, right?
So
very interesting.
So that kind of leads us. I mean, you actually ended up. You and Jake have a PhD in the same field of study, right?
Yeah, that's correct.
So you guys, what all like are the letters contained after your guys' name as far as that last field of study, your PhD, you know, because that I found that extremely interesting when I looked at it, because it's almost like, I mean, the couple of times that I've talked to Jake about you, first off, he keeps telling me that the internet wants you on the show, and that everybody keeps asking about JP. So he was like, you need to make sure you do this interview with JP ASAP. Otherwise, the internet's going to get rambunctious. But I didn't realize up until we sent you this email that you guys actually have that same PhD. So how did that kind of leads into how you guys met too, right?
It did, yeah. So after I finished my master's in Kaiserslautern, I was looking for a PhD originally in this marine sponge research. It like really fascinated me, and also the prospect of diving into the Mediterranean Sea for like your work was kind of exciting too as a prospect. But then that didn't happen. And I ended up looking towards a place where you could do research without the lack of funding. And that was something that hung over my master's work like a Damocles sword, that towards the end of the year when the funding was running out, we had troubles like running a PCR. And that is so basic, and it costs little to nothing, that I was shocked, like that I had to ask, can I run this PCR, or like, is that gonna like bring us trouble? Yeah. And the main like problem for this was funding. So I was looking at the time, like where is research done in Europe, because I didn't want to go too far away. Where is research done in Europe with a proper financial background? And that at one point turned me towards Luxembourg. Like Luxembourg is fantastic in that regard, that they are pumping massive amounts of financial power into their science sector. And so I learned about this Luxembourg Institute of Health, it's called now. Before, when I applied, it was still the CRP Santé. And basically they had different fields that they were working in. They have an oncology field, they have a statistics field, in many different areas. And one part was immunology, and with a focus on virology. And I could see myself doing something like that. I had little to no experience in virology. I had a couple of courses at university in the field of infectious diseases, so I knew the basics. And I thought, what better can you do to learn the in-depth knowledge about this by studying it for a PhD, right? And it fascinated me massively. So I applied to Professor Müller's lab at CRP Santé, his department of immunology, it was back then, and got hauled in for an interview. And he called me at in the afternoon. I was just having my third glass of wine in the evening, enjoying a day off in the sun. It was in the summer, nice and warm, and I didn't think about work at that point. And he calls me, and for me, doing all this in English back then was new. And he said, "Do you have time for an interview? Can we talk a little about your work and what you want to do for me?" And I was like, okay, I can't really hang up right now. So I stomach through that. About half an hour later, this was done, and he said, "All right, let's bring you in for a formal interview." And the interview process, and that was where this whole thing like turned. He sent me. So let me back up. The idea at Claude Müller's lab for doing interviews, it's actually quite interesting. So they do a full day interview. It lasts the whole day. You get 1 week before the interview, you get a title for a presentation that you have to give to the lab. And then you like go there, you give the presentation, they're going to ask you a ton of questions. Then they give you 2 recent scientific papers in the same area field of your presentation. You have to like work yourself through them and then present them. And then they're going to ask you questions about these papers. And then you have additional interviews with the individual people in the lab. And that whole procedure, in my case, lasted, I think, 7 hours until it was done. quite heavy, but you know what you're getting yourself into after you've done that, right? You can make a decision and they can make a decision. And I think that is very, very helpful because you want to know whom you're going to work with for the next couple of years. And that was where like the things turned, because the interview question that he wanted me to address in my presentation was not about virology, even though I applied for that. It was about, can you talk about the B-cell receptor repertoire in health and disease? That was the question. And I was sitting there when I got the title, and I had to like work for at least an hour or two to understand that title by itself, because B-cell receptor repertoire, what does that mean? I didn't know. I knew what a B-cell was. I knew what a B-cell receptor was. I knew that, they're different. So I put one and one together and said, okay, repertoire is like the entity of the different receptors that a human has in its body. And already while doing that, I started thinking about, okay, how can this be applied in health and disease? Like how does it change? What happens if you get infected? What happens if you have an autoimmune disease or cancer? Like, this is all things that are involved in that. And then I put together a like 1 hour presentation based on that, figuring out basically on the internet what this is, B-cell receptor repertoire, and how you can look at it in health and disease. And it was one of these points where I realized, shit, there is so much knowledge on the internet anytime that you can just use to study whatever you want at any time point. There's just one major caveat, and that is the financial barrier if you want to study it using scientific publications, because they're not always, actually the majority is not available for free, right? This is it's one of the main problems, I think, in science, is that we are producing results and we are producing publications and scientific results, and they're not accessible by the public unless you want to pay for it. And, when you look at what Nature or Science, these different journals, what they're charging for an article, as a person, as an individual, you cannot afford that. For like studying this particular field, I had to read like 100 papers. If each paper costs $30, how can you pay for that? That's just impossible, right?
Yeah.
So
that's something that I love about just doing these interviews in general, along with outside of very specific trade secrets, being able to put out data and being able to put out experiments and being able to read like studies and everything like that. That's one of my favorite things to do as an RN is we change policies all the time at the hospital, because our intensivists will, the running joke is they'll go to a conference and hear something new, and then they come back and we're now giving boluses of lactated ringers instead of normal saline. And we're like, okay, why are we doing that? And I always like going online and trying to read those studies. But like you said, sometimes you get on there and, you may find the actual study that they may have been exposed to at this conference, but costs $40, so then I can't actually understand the dynamics behind why we're switching what type of fluid we're bolusing. I just, at that point am following blindly and attempting to just understand, hey, it's making my patient's blood pressure go up. So that's a good thing.
Yeah. And the great thing about the internet itself is that it always finds solution for these problems. One that became like a thing already back then was basically scientific colleagues exchanging literature, right? A lot of my friends were still enrolled at universities back then. And so I hit them up and asked, like, hey, can you have a look whether your library has this paper available, and can you send that to me? And that was how I got through that. That was how I was able to like pull information from resources that should be available for me but weren't. And right now this has evolved into something even bigger, because we have social media attacking this problem. For example, there's ResearchGate, which is a fantastic source to just get any kind of publication, and it's completely legal too, right? You just hit up the author and can say, hey, can you send me that paper that you've written about like Ebola? And he's just sending that to you, and you can read it and you can work with it. And that is fantastic.
Yeah. And then being able to share that data, it just benefits everybody in the long run.
Exactly.
So you ended up, you got the same type of degree as Jake, and then you ended up moving after that to Boston, right? And working in bioinformatics at a startup there.
Yeah. Let's back up a little bit and go further into the part where I studied and actually met Jacob Glanville. The idea of my field of research after I applied and had this crazy interview was to study B-cell receptor repertoires in health and disease. And, it came to me as a surprise, but it turned out to be super exciting. I had a great colleague, Axel Dubois, who was a vet, and he started this entire initiative together with Professor Claude Müller at the Luxembourg Institute of Health to start looking at B-cell receptors in health and disease. And the reason why they did that and why this became such an exciting field is because around the same time, humanity has invented like a revolutionizing technology, and that was high throughput DNA sequencing. So they built an apparatus where instead of like with conventional Sanger sequencing, you could sequence like 1,000 B cells, 1,000 like receptors. And like with this thing, suddenly you could sequence millions of them. Up to now, the standard tool that we're using is a Illumina MiSeq that can easily sequence 30 million sequences, right? So they said, well, there must be a way how we can sequence an individual's immune repertoire, as it's called, like a B cell and or T cell repertoire, and figure out how it got reshaped by the past exposure of a pathogen. So the ultimate goal of all these studies was, I take your blood and I sequence that, and I have a database of known B cell clones, and I look into this and I say, oh, you've been infected with measles and you got your flu shots in 2012, 2013, 2014, and you've been vaccinated against hepatitis B, and I think you should check because you look like you got HIV. Like that was the idea that Claude Müller had. And back then this was a like revolutionizing idea. It was phenomenal. Ended
just
up
lays it out there for you.
Yeah, exactly, right? On the prick
like reading
of
a
the finger.
book. Yeah, exactly.
And while the fundamental idea of this was fantastic, it turned out that it was way more complicated, as it usually goes with science, right? You have a great idea, and then you start getting into the weeds, and you figure out that this is way more complicated than you thought. And one of the first hurdles that Claude and my colleague Axel had was that generating 1 million sequences is great, but how do you look at that? You cannot just pump them into your Excel sheet and like scroll through, right? And so initially we had hired a bioinformatician that was helping us with this. Her name's Anke, and she turned out to be also my mentor in this field. But at one point she got pregnant, so she like dropped out of the lab there. And then Claude was asking around, all right, who can analyze all these data sets for us? Like who can work these millions of sequences? And I had some exposure to informatics and like programming a little bit. And I had my little brother Christian, who was an informaticist student at the time. And so I hit him up and said, like, dude, I have millions of strings here that need to be sorted and worked through. Can you help me with that? And so over the time, I transitioned from just a molecular biologist / chemist into being like a full-blown bioinformatician. And my thesis also like changed completely in that project, like my entire PhD work, turning more and more into a computational immunology project, where the question was not anymore, what can we figure out in the B-cell repertoire of a patient, but how can we do that? So how do we design an algorithm that sorts through all of these sequences and then like draws meaningful conclusions out of there? And that was a point where that's something really great about Luxembourg, is that they let you go to a lot of conferences. Where I met Jake at a conference in the Tuscany in Italy.
With, talking about
it was a Gordon conference on antibody biology and engineering, where like a lot of people were presenting their work on standard antibody research. And Jake was one of these people that was fortunate to be in Stanford back at the time to use computational immunology to look at antibodies at large scale. So it was the exact same thing that I was doing. Although he had a little bit more on the engineering part. Me, it was a little bit more in health and disease, but essentially it was, how can we apply mathematical and computational algorithms to figure out how our antibodies are made? And he gave a kick-ass presentation at that day that like wowed a lot of the big shots in the field that were sitting there, and you know, they didn't know him. He was a PhD student, just started, similar to me, and then he was like giving such a wonderful presentations about why you cannot use a standard flu shot, I think it was, to like create a successful immunity against influenza. It was fantastic. And the conference, it actually was one of the best conferences I've ever been to, and I've been to like over 20 in the course of my PhD. But the amount of interaction with PhD students and also the big shots, it was just phenomenal. And the Gordon conference basically tries to achieve that by putting everyone in a nice resort somewhere on a mountain where they can't run away, and then they leave them there for a week. And it's just highly concentrated science. Everyone is from the same field. They are like highly specialized. This one was antibody biology and engineering. So these were all antibody scientists around you. And you just get so much interaction. It was fantastic. At the same time, there's a lot of party going on at these conferences. I thought I've seen it all in high school and college times, but that was hardcore.
Oh no.
So were you and Jake?
I have a feeling it's
kind of like the only two at that conference that were working in that close of a field with one another?
No, there were like a couple of other guys too. Like there was a lot of students that just like where the institutes similar to mine just embarked on that field. And I have to say, most of my professional network stems from that time. Like I got to know so many people back at that conference. Gotcha. That I'm still very well connected with these days. And you see like how these things evolve. A lot of them stayed in academia. They didn't transit to industry like I did. But this field was new back then. It was completely nascent, and now it grew up into one of the important pillars of immunological research.
That's funny, because when you're explaining that story, all I could see in my head is the Spider-Man meme where there's the two Spider-Men pointing at each other. They're like, "Hey, wait, you're me. I'm you. We're doing the same thing."
No, already back then, Jake was ahead of me in this kind of research. One thing that you need for doing cutting edge research is money, and a lot of that, and in terms of scientific funding. And being at Stanford just set him up for success, right? I mean, he was working with Scott Boyd and Mark Davis, who are two like really big shots in the field. Like everyone knows Mark Davis in my field. This is and so he had all the money that he needed to conduct studies in many different fields. And just for comparison, when I finished my PhD, I had 5 publications, if I remember correctly, like 5 scientific publications, which was really great for a PhD student in Luxembourg. Jake had 20. Like it's just another level. And he is in many ways on another level. Like also in Stanford, you don't normally publish 20 articles in the course of your PhD, but the funding situation really, really helped, obviously.
Oh, I'm sure. Yeah. So I kind of want to really just keep exploring this relationship with Jake. So we can kind of lightly touch on Boston, but I really want to focus on like you going from Boston to spending 2 weeks in Guatemala.
Sure. I mean, the idea in Boston was, so the time after my PhD graduation, and that was like a lengthy battle to get my thesis through and to do the defense. It's not easy. You have to like organize a lot of stuff at the time that you're already out of the lab, so you're not getting paid anymore. You have to basically see where you want to live and where you want to go next at the same time. So there's a lot of things raining down on you that you have to sort out. And my wife, back then still my girlfriend, we like decided, okay, let's go over the pond. Let's try to find something outside of Europe while we still can, so to say, right? When we're young and we want to explore new continents and new ways, you better do that before you're 40. And she said she wanted to look at Canada, and she got a postdoc over there. And at the same time, I tried to get a job in Canada as well, and I got a postdoc position at the University of Toronto in an immunology lab over there. That was very, very promising. However, because I hadn't graduated yet and I didn't have my like PhD certificate in my hand that I could use to cross the border and say I want to work as a postdoc, Canada basically said like, nope, that's not happening. and we had to find another way to get by. And the thing that came up at that time was a small startup from Belgium. It's called BISC Global, stands for Bioinformatics and Statistics Consulting, and they wanted to work with my wife Fleur, and they said, you want to come in as a consultant for us. And we didn't know about consulting, but it looked exciting because they told us, you like solving problems, right? And like solving, really cracking tough nuts. We have them on a weekly basis for you. There's companies that want to solve really difficult computational problems. They need somebody to do that. They don't have the manpower. They don't have the people, don't have the expertise. And we're going to bring them in and like solve this. And the idea of BISC Global was to work on site. So you're not just sitting at home working from your like home office, but you're going actually on site and work with the company there. And they were like interviewing her and everything was great. And she was on board with that. And they were asking, so what's your plans? And she said, well, we're still looking for a job for my partner. And they were, what's he doing? Oh, he's a bioinformaticist as well. They're like, well, that's great. Let's have an interview, and then they decided to take us both on into their newly formed company. But we said we don't want to work in Belgium right now. Maybe later, but right now Belgium is not an option. And Martin Braspenning, the CEO of that company, said, well, I always thought about making this thing global, hence the name BISC Global. So why don't you guys start BISC in the US for us? And we were like, whoa, that's a big step. We just graduated with our PhDs. We did 1 year in Canada. And now suddenly somebody trusts us with building a department of his company that he just founded a year or so ago in the US. So let's do it, right? This was exciting. This was a great experience. So we wanted to get on with that. And he put us, like he said, either you're going to do it in Boston or you're going to do it in San Francisco, because we want to be where everyone is in the biotech field, right? And before we could make a decision, I remember that call. He said, well, you guys love Canada, right? So I think you should go to Boston because the weather is similar. And I was like, God damn it. I would so love to go to San Francisco, right? But okay, said and done. We went to Boston, started building the department there with our supervisor, Dan Ryder. We hired like a couple of months after we started, and was very successful. Really liked the time there. I worked with a ton of different pharma companies in all different fields, and I gained so much knowledge on how things are done in the industrial field of research, because I came from academia, right? I only knew how things run in academia. It's like endless funding raising, working in the lab under difficult conditions, and then publishing or perishing, endless postdocs, hopefully a professorship at one point. So I didn't really like that. So I wanted to know how it's done in industry, but you don't easily transit from academia to industry. And BISC Global gave me that chance to do exactly this, like to find a way and a foothold in industry. And that was about that time. We moved to Boston I think we landed on the 31st of December. So New Year's Eve in Boston, minus 40 degrees centigrade. And I think that's more or less the same in Fahrenheit. So it was bitter cold. And the one thing we said, we want to do a vacation this year, and it's got to be somewhere where it's warm. Like we want to go somewhere where it's nice and warm. And we were thinking, well, now that we're on this side of the world, we should go somewhere middle South America, just explore these countries. We've been a lot in Asia, East Asia, Southeast Asia, and like exploring these countries while we were still in Europe, just experiencing new cultures, and we love to like try different foods and stuff. And when we were over here in the US, we said, let's go south. Let's figure out what's down there and how these countries are. And we couldn't really decide on which country to hit up. And I know from experience that it's much nicer to experience a country if you know somebody there, that you're not just the average tourist that runs around, but if somebody is there that knows the area, can take you around, can show you things that you would never see otherwise, that is just adding so much to that experience. And we looked at the map and I saw, hey, Guatemala. Wasn't Jake growing up in Guatemala, I thought, right? And I've met Jake so many times at different conferences, and we became really good friends over the time. I thought, well, let's just ask him if he wants to spend some time with us in Guate and show us where he grew up. And so I texted him, and he was like, fuck yeah, if I can say that here. Let's do this, right? And that's the way how Jake usually talks. And said and done.
A passionate human.
Oh yes, for sure.
He does not like hide it. He wears it on his sleeve 100% of the time.
It definitely does. So said and done. We made a new friend in Boston. Her name is Charlotte Byrne. She works for a large pharma company there as well. She was in machine learning and AI back at the time. And we asked her, do you want to come along? Just, let's do some great time in Guatemala. It's going to be awesome. And so Charlotte, my wife Fleur, and me flew down to Guatemala, and Jake came from San Francisco over for the first of our 2 weeks. And right from the start, this was just working out super great. We went to the to Posada de Santiago at Lake Atitlan, where Jake grew up and where his father still has this, or had back then, this hotel / bungalow posada that you can like stay over and like eat at the restaurant. It's really phenomenal to visit this. I don't know how it is growing up there, but it is phenomenal visiting it. And Jake, on the first evening, I remember he puts out a piece of paper and he said, okay, let's figure out what we can put into this 1 week of vacation that we have. And we ended up with a plan that was enough to like spend half a year in Guatemala. That's just Jake's throughput, right? He likes to do things at a pace that other people are just usually not able to keep up with. So one of the really, really nice adventures that we went on was like climbing one of these volcanoes that this area has around there. It was the San Pedro. And you have to imagine that you're already on like 1,500 meters above sea level at Lake Atitlan, and then you climb another 1,500 meters on San Pedro. Like the peak, I think, is roughly around 3,000 meters. So for somebody who's not used to that and who's been living at sea level most of the time, that gets really cumbersome to like climb up these mountains. So the four of us in a 12-hour journey climbed up and down San Pedro. We got stuck at the top with a thunderstorm surprising us, and still pressed on. Suddenly we heard like a lightning hit a tree just 50 meters away from us. It was so damn loud. We took some shelter underneath a rock there, had some chocolate and beer, like 100 meters away from the top. And after the storm was past more or less, we said, all right, let's do this. Let's climb back on top. It was really, really some great time we had there. And back home, after descending the volcano, which turned out to be even more of a hassle than climbing it up. At one point, your calves and your legs are just giving in. It's just too much strain on that. So we're back at the Posada, and Jake already on the way to the Posada ordered, margaritas and steaks, so we could replenish our thirsty souls. And back at the Posada in the hot tub there, like we talked a lot about Jake's work and Jake's vision at Distributed Bio, like what he's up to, what's going on. Also in the field of universal influenza research that he did at the Posada there. He showed us the labs the next day. And at one point, I just bluntly asked him, I said, dude, if you ever are in need for more computational power at your company, just let me know. And he's like, damn, yes, I actually wanted to talk to you about that already before, but I thought you were occupied with BISC Global, right? And so I didn't want to intervene there. And I said, yeah, but the stuff that you were doing is just phenomenal, and I would love to come on board. And so he said, well, hit me up with a formal interview request, and send me your CV and what you've been doing, and let's bring you in. So that was how this started in Guatemala.
And you had a unique interview experience at your first, that job with developing NPS. But then also Jake's interview process for bringing you into Distributed Bio was unique as well, correct?
Absolutely. Like one of the things that Jake immediately said is, we're friends, but that's not like reason enough to hire you. I like you and I know what you've been doing during your PhD, because we've been doing the same thing more or less. But one of the things that was very important to him was that I fit with the team. So the thing that he wanted to set up for me is that I come on site and that we like work together, not only him and me, but me and the team. And I think this is absolutely crucial, and is one of the reasons why distributed bio is so successful, is because you have a lot of very, like he always says, we have alphas in the company everywhere, right? And a lot of them are like very, very strong-minded individuals, and there needs to be a way how they can function with each other and work with each other. And so when I came to distributed bio in the first place, this was in I think February 2019. I worked with Southern back then. So they put me into Southern's office, and Southern was very, very happy to have a fellow immunologist sitting in the office and, to talk science to. But I also relatively quickly realized that Southern is like miles ahead of me in terms of immunology. This woman is just a force of nature. Textbook immunology knowledge is out of this world and knows basically everything that's happening out there at the same time. It's just fantastic. And so we had a great connection immediately, and I got the chance to work with a couple of other individuals over the time, mainly in analyzing their data, because that is my job, right? I'm a computational scientist, a computational immunologist. So what I do best is analyzing antibody and immunological data. And so the company had a bunch of tasks laying around that needed attention that I was adhering to, and at the same time, they wanted to modernize their computational frameworks. And Jake had interviewed a software engineer. His name is Timothy Young. He was a young computer scientist that wants to go a little bit more into the industrial world of applying informatics. And one of that points is software engineering. And so I worked with Tim on trying to modernize the layout of Jake's Genesis platform, and to make it more usable for the scientists on a day-to-day level. And we did about a 2 weeks. It was about a 2 weeks interview, because I was there for 2 weeks working with this company, and also seeing how things are working out with the team. And I felt I had a good connection, but Jake ultimately said, I got to take this back to my team, and I got to ask them whether they see you as a good fit or not. And he did. And lucky for me, the answer was yes. And after that, we embarked on a wonderful journey of getting a work visa for the United States if you're not a United States citizen, which I think as a German white male, I have like good chances immediately. But this is a tough process. Like going through writing applications for visa is not easy. And Southern actually helped me a lot with that as well, because she went through the same process. I think she talked about it in her podcast. And she had a fantastic team of lawyers that she referred me to, and together with them, I worked it out. That was one hell of a thing.
Yeah, and H-1B is no joke when it comes to filling out those types of forms.
No, I got an 01 for this one. So
did you got an 01?
Yeah.
So even more in depth.
Yeah, there was a lot of paperwork to put together. Luckily, I had a ton of contacts through my work with BISC Global, and also before academia, that I could leverage with this, that could vouch for me that I am an individual with exceptional capabilities. And so that worked out.
Right. Yeah. And so actually, speaking of things working out, your degree path and kind of ending up on the same PhD landscape that Jake was on actually worked out for the responsibilities that you ended up taking over at DBio, because you kind of took over some of his responsibilities so that he could focus more on being the CEO and kind of keeping the vision and guiding the company. And now you're heading up the computational and informatics efforts with an amazing team, including a 17-year-old computational immunologist, right, in Aishani.
Yeah.
And so having that group of people, what did it feel like when you first kind of took over those, that type of program and started working with this team and having those people report up to you, having those alpha personalities and stuff like that? How did you navigate that, and how has it been since you have really been the head of that computational informatics?
Yeah, it actually was far easier than it sounds. So, I mean, as you pointed out, Jake was the computational immunologist of his company. That was his central role as a CSO before he became CEO. And he identifies bottlenecks. That's how he hires people. Like he sees where is there a lack of expertise or manpower in my company, and how can I fix that? And one point for like bringing me in was, well, I'm the only guy who's analyzing all these sequences, so I need somebody to like help me out at least with it, if not replace me ultimately. So I am freed up more for my like management responsibilities, as actually being a CEO. And with my skill set, that just fitted beautifully, because I did nothing else the like 7 years before that in analyzing antibody sequences in a different like environment than antibody engineering. But during my time at BISC Global, I worked with, I think, 3 companies in depth on antibody engineering protocols. So I had an experience that was just perfect for distributed bio. And when I started working there initially, Jake handed off a lot of work that was backlogged on analyzing data. And I started like crunching through this, just, crunching numbers, getting things done, and like supporting the team wherever possible. In parallel, he did the same on his part as much as he could. And together, like we worked ourselves through that backlog. And at one point he said, actually I have a bunch of people here that are doing all different things in the informatics. Why don't you talk to them, right? And so over the course of a couple of months, I had the chance to meet those fantastic individuals. Tim I knew already from before, and in the meantime, he turned from an intern into an FTE, hired full-time as a software engineer. So I knew him already and was great working with him, and is great working with him. And then I met Rachel Hovde already while I was visiting Distributed Bio in February, but later on then also when she was like working with us at Distributed Bio. And she is a fantastic mathematician, statistician, and machine learning person. So her work was pretty much independent from mine. She uses the data that I produce, but she's not necessarily working as the person that reports to me in that regard. And then I have Aishani on the side, who is, you had her in the interview here. This woman is just fantastic. Just 17 years old, but already working at a level that other people have to like get their degrees for to like compete with her. And she's already doing it like now while doing high school, and now going to Harvard. It's just fantastic. And all of them together like form this environment of like scientific excellence that I wouldn't have thought of like being possible. And right about that time that I was like talking to all of them and like putting them together into a team, Jake introduced me to a new intern that he hired. Her name is Michali Isaki, if I say that correctly. And she came from a microbiology background, and she said, I want to really learn about this computational thing that you guys are doing. Can you teach me? And in the beginning, I was a little bit hesitant because it would require a lot of my time to like teach an individual how to do computational analysis. But Jake told me, dude, you just got to like feel it out, because she gets things super freaking fast. And it was exactly that. We had about 1 week, maybe 2 weeks of interactions where I sat with her about an hour every day, sometimes 2, to like go through the basics of how you analyze data, how you manipulate data in the context of immunology or biology. And after 2 weeks, I could give her like individual tasks. I could tell her, all right, let's figure out the length distribution of HA proteins of influenza in our data set. And let's curate that and like cut everything that is longer than 800 amino acids and shorter than 300 amino acids away from that. These are like standard tasks of data manipulation that a computational scientist does. But to know how to do that in just 2 weeks is phenomenal. So ultimately, what came together as a team is really a group of individual scientists that I can point at a problem and say, this needs to be done. And they just do it and never cease to amaze me. I actually never had a situation where I was like, dude, you really need to get on top of your game here and do something, like be that kind of guy that needs to motivate or push people to get the job done. And on the contrary, they usually are done way faster with what I give them than I anticipate, and B, they usually excel in everything that I do. Like if I tell them do A and B, they add C, D, E, and F on top of it because they know that this will be the next steps. Yeah, it's fantastic.
And that right there is what I think makes DBio different, right? Because there's a lot of organizations, and I think that it's, way to an extremely lesser extent. I am by no means comparing like our team here at Apex to the level of intellect and like just capability that DBio has. But I kind of did the same thing with our team here, right? And that's why I think Jake and us we're working so well together, and we just mesh, because your guys' culture is, there's an issue, we're going to, like, it's almost like a sick neuroticism, that it's like there's a problem and it doesn't leave, and you can tell me if this happens to you, but if there's a problem in my head, it does not leave my brain. Like, it's just constantly rumbling around in there until I can figure out how to solve it, and then I'm like, okay, now I can relax. And like, everybody that I've interacted with at Distributed Bio seems like they're the exact same way. That, you're in your car driving home from the lab and your brain is like, son of a bitch, I wasn't able to solve that today. Like, why? Oh my God. And it just nags at you. And assembling a team of people centered around that type of personality type rather than academic excellence or other stuff, because you can be extremely textbook academic excellent, publish a whole bunch of papers and everything else, but you can't teach somebody to have that type of dedication. And that's the difference between the team at DBio and other people that I've interacted with in the scientific community, is that drive.
Yep.
And it's the same thing with us at Apex, because none of us are marketing and communicators, and I talk about that all the time. We're not traditionally trained. We have our street degree in marketing and communications, but it really just stems from the fact that you have a nurse with a minor in clinical psychology that marries like the military experience of human resources and intelligence with science. You have a pre-med student with degrees in chemistry and biology, and that's Jacob, our my producer and chief strategist, that he's so good at logical problem solving. Like, that scientific method is just, okay, here's how I tell him I need to be able to get here. And he's like, okay, here's the steps that we need to take in order to get there. And then RJ was exercise science and management, and now manages operations and is the co-host of the show. You kind of bring those personality types together, but all three of us have a sick dedication to what the craft is. RJ's really stems, I think, from his bodybuilding career. You can't see him right now, but this man is 260 plus pounds of muscle.
Jeez.
Yeah. So, and that takes a lot of dedication to diet, to training, to everything. And it translates directly into the business world, which is why, I'm able to stay up till 2:00 in the morning talking to Jake or Aishani on FaceTime, trying to figure out live stream stuff, because that's just what I want to do. I know it's going to benefit things, and it makes me happy to stay up until 2 or 3 o'clock in the morning working on stuff, because even if I tried to go to sleep, I wouldn't be able to sleep if I hadn't figured out how to get it done.
Absolutely. It doesn't surprise me a little, not at all, that you are, like forming a partnership with Distributed Bio. That's exactly the kind of mindset that we have. You don't sleep until it's done. And, that can cause some issues, but it is actually very, very satisfying to work with them in that regard, because no matter how hard a problem is, Jake usually finds new ways how to solve problems that other people didn't even know they had, and like surprise the world with this. And what he does then, he gives them to one of his usually interns, which is actually very, very interesting. That just gets interns in and like presents them with a problem that other people write Ph.D. theses about and like spend 6 years of work. And he said, no, you got to get this going as a product. So think about, what do you need to do to make this available to our customers, to the people that want to work with us and pay for the work? And usually these people then excel and get it done. And that's how he built his entire like toolbox of different things that he can offer to clients. It's fantastic.
And I'll wrap that thought process up. There's a beautiful quote. The specific general is escaping me right now. I want to say it's Patton, but I'm sure the listener will correct me if it's not. But he says, never tell somebody how to do something. Tell them what to do and be pleasantly surprised by their ingenuity.
That fits very well, yes.
And I believe that is the epitome of knowing that you have a good team, is when you can tell somebody what you need done, not how to do it, and just wait. Because your process that you've had, and the death of the absolute death of any type of progress, is the statement, we've always done it this way.
Oh my God, yes.
Right. And that makes me want to just put my head through a wall anytime that because we've dealt with that like crazy over the last 2 years that Apex has been in existence. So it's like, hey guys, like we can take this one piece of content, distribute it across 15 different places, and completely eliminate your workload. And they're like, oh well, yeah, but we've kind of done this way. We already have a marketing person assigned to that, and it's working okay, so we're just going to keep doing it that way. I'm like, okay, well, that's fine, I guess.
Too stubborn.
Right. And refusing to change. But when you give somebody that challenge and they have the personality type that your team does, and everybody within the Centivax and DBio world has, they figure out these new innovative ways to solve issues. And then you're like, oh man, like, hey, we've been doing this 15-step process, and this, 17-year-old just came in and figured out how to do it in 2 steps.
Yeah.
That's awesome.
It's fantastic. But I also have to say, it's not for everyone. Like this kind of like really, it is also very, very fast paced usually. I think one of the things that Jake lacks, and which is the reason why he's a very good problem solver, is patience. Like this thing needs to happen, and needs to happen now, and it frustrates him immensely if it doesn't happen in a timely manner. And then so that leads to like a very, very fast paced work environment, and that is hard to navigate. I mean, for me, I'm kind of like not the standard distributed bio employee in that regard, right? I have a PhD degree. I went through the standard academic process, and coming into that was suddenly being surrounded by a bee swarm. It was amazing how much productivity these people can like crank into a single day. And I've worked with a lot of pharma companies in my short time at BISC Global. Like they would run circles around most of them. It's really impressive.
Yeah, and which is why I'm super excited that you guys are working on all of this stuff with COVID-19 and the anti-venom programs, the Centivax flu vaccine programs. I mean, there's so many different things that we could explore, which I'm sure we'll explore at a later date. But just to wrap all of this up, and kind of give us a nice little ending to the episode, why don't we just kind of explore, this last little bit? I know that we've explored the COVID-19 programs with some of the other DBio employees and stuff. But from your vision, as far as being kind of this lead of young scientists in the computational informatics world, what I guess my question is, there's a lot of other companies that are working on these products, and you just mentioned that DBio could potentially run circles a lot of these bigger companies. Why do you believe that the team that you have and the approaches that you guys are taking are going to be the ones that make the antigen style or antibody cures and stuff like that available quicker, safer, rather than some of these other companies that are researching the same thing?
Yeah. So like, let me say that the way we've approached COVID-19 was like reacting fast, right? Jake back in January already said, we got to do something about this. And he put, not as he usually does, one person, but actually 2 people. So he doubled the superpowers on that virus and said, hey, Jack and Sharad, which are 2 really, really amazing scientists in our team, you got to deal with this. And I'll leave that to you, like the beginning and strategy, and hash it out and get going. And then this thing became like really bad. And then he focused the entire almost the entire team of Distributed Bio on that problem during the shutdown, right? When shelter in place was called out in California, he said, anyone who wants to come to work and work on COVID-19 is welcome, but it's a voluntary basis. And almost the entire team volunteered. And then they started like crunching down on this part. And I've never seen our discovery process going through that quickly. It was really fantastic. We implemented shift work. It was 7 days a week. So making our anyway super fast discovery process even faster. Jake was overarching the data analysis part on this one, partially because I'm stuck here in Europe, and the interaction with the team are a little bit more difficult right now. And I was more on the prediction part, like when we got our first results and we look at the antibody structure, like how does it change? Do the changes that we see in this antibody make sense? Sort of like a confirmation at the back, saying like this actually makes sense. It's not only that we see that it works, but also informatically it makes sense that it does work. And then now, and this is where this entire thing becomes like really, really funny, is we are clashing right now with a regulatory apparatus that is very, very written in stone, right? And Distributed Bio, the idea of Distributed Bio is there a way to hack it? Like, can we make it better? Can we make it faster? Can we improve it? And we have this beautiful molecule that we can use potentially as a therapeutic against SARS-CoV-2. But now we have to make sure that it's safe and that we can use it in humans without any complications. Because the last thing that we want is to give it to someone and like cause something bad, right? So we want to make sure that this thing is safe and that this thing works. And our countries, whether it's in Europe or in the US or in Asia, they have regulatory systems in place to make sure that this is the case. And these regulatory systems, they are difficult to navigate. And this is something that we have been never exposed to before, because we usually end our part of the therapeutic invention process with discovering the antibody, making it nice in terms of like stability and like low liabilities and whatever not, and hand that over to a large company that ordered us to make these antibodies, and they take it forward. Now we want to do it ourselves. So we are now confronted with this entire apparatus of regulatory systems that you have to go through. Like manufacturing, you have to make this thing in large scale, but it has to be safe, that you can give it to a human. Then you have to do like tests for efficacy, that this thing actually does something beneficial, to make tests for safety that it doesn't do something bad. And Jake wants to do all of this in record time. So he's applying the Distributed Bio strategy and idea to a largely, I would say, encrusted regulatory process. And that's going to be like a really, really tough challenge. So lucky for us, we've brought in, over the last couple of months, we brought in people that can help us with this. Like Sausan, at the top of our science efforts as CSO, she's a fantastic resource to dip into, because she has brought an antibody molecule as a therapeutic all the way from discovery through IND filing, through the phase clinical studies, into actual patients. So she has seen it all. And we just hired, it is. I don't know how she did that, but I know that Sausan is a force of nature. So if you give her a task, she gets it done. She always does. And so with this part, we are relying heavily on her expertise, on her knowledge in this. And we've brought in a colleague of her, Dave Tsao, who is working on the in vivo part and pharmacology aspects, and he knows all these things as well. And there's more individuals coming on the Centivax side to like add on top of this. Now, here's the main point, right? Sausan, Dave Tsao, and all of them have worked in this field with Pfizer at the back. That's where they come from. So they had a pharma giant organizing everything around them. And we have to do this now, partnering up with different groups, CROs. There's like Bill and Melinda Gates Foundation featured supported groups like COVID Consortium, and and many others. Jake is talking to the military actively to get them involved into that, because they have a war chest for exactly this problem, because the pandemic is a problem for the country, but also for the military. So they're very, very keen on helping with moving these things forward. And there's about, I think by now, 300 other companies that are working on something similar, whether it's repurposing of other drugs or antibody discovery, plasma reusage, vaccine design. There's like so many different teams working on this. And the one thing that we are competing against with is the virus and not each other. And that has been also the essence in some of the conversations that we had, where people say, yeah, you got your molecules, and we have roughly 50 molecules right now that we want to move forward with. And there's another company that has 20, and there's another company that has 10. Let's put them all together and see which ones work best. That is the strategy we would like to see. However, that's not possible like that. It's just regulatory wise, you cannot just do that. To test the molecules individually, which is time and costly. So you need a lot of time, you need a lot of money to do these things. And I was actually very, very surprised by the amount of positive feedback that we got from all sides. Like whoever we talked to, they were willing to like do things as fast as possible and immediately. They were like, yeah, just send us what you got, and we get going as fast as possible. But even as fast as possible, it takes time. And that is the main thing we're fighting right now, is time.
And I think that having people understand that is phenomenal. Is that the amount of user effort sometimes when you put you can throw 1,500 people at a problem, but if the problem takes a month worth of cooking in order to focus, that you regardless,
what good is it?
Yeah, 15 people working on it or one. I'll compare it to like a good brisket. You can't, if you cook that bad boy on high heat for 20 minutes, it's going to be way less productive than if you let it cook for 16 hours at low heat.
Yeah, that is so true.
Sometimes things just take time if you really want them to be the best product possible. And so that's, my message to the listeners right now is you be confident that there are people out there working and kicking ass when it comes to putting together these issues and solving the problems. But understand that if we really do want the best possible product with the highest possible efficacy and the highest affinity to neutralizing things like this, we have to make sure that we give it its due diligence and its time correctly. So Absolutely. There are a lot of extremely intelligent humans working on this problem. They're going to be dedicating their time, even, like I said, driving down the highway after they get out of the lab, still thinking about issues because they weren't able to solve them that day. And be confident that there are people working on it, and don't believe some of these posts, that are going out on social media or kind of ravaging the internet right now that this is apocalyptic, because I think that that's kind of the mentality that I've encountered with some people, is that this is the apocalypse. And I think that we as the human race have way too many people out there that are working on this issue that are going to get it solved for it to be deemed completely apocalyptic. So
we're going to beat this thing. That is for sure. There's going to be a post COVID-19 time coming up. The question is, how fast do we get to it? And if I would have a wish on that, I actually would wish that we would succeed with repurposing drugs, because it's the fastest way. We know they work. We know they're safe. We could use them right away. That would be fantastic. The second fastest way of getting things done is with antibody therapeutics, which is what we are working on. And then on the long run, the third arm of our war toolbox that we have at hand against this virus is vaccines. But that's a long-term thing, and it's more for preventing that this thing becomes a new influenza that will be coming back every year or something. So when we have a vaccine, we can eradicate it. But right now, for treating the people, especially the ones at the front lines, and especially the ones that are highly susceptible, meaning the elderly people or people with pre-existing conditions like diabetes or asthma, what we need for them is a treatment right now. And that will be most likely like antibody therapeutics. So it's great that so many people are working on this, and one of us will succeed. I don't even care who it is. If we succeed, that is great. But if somebody else succeeds, we still win this battle, and that is what it's all about.
Amen. Yep. This is a humanity problem. It's not something, that's specific to one country or one group of people. So that is a great outlook. Well, JP, thank you for hopping on the show with us today. I appreciate it. This is definitely a very interesting, in-depth look at the other side of DBio, especially since you're across the pond right now, and kind of, doing this interview based on bandwidth linking because the Wi-Fi is issues, and
we interrupted his wine time.
People, yeah, I think we might be on our third glass at this point.
Yeah, so it was a great discussion. Thanks for working the times out with us. We appreciate it.
Thanks for having me on. This was really great.
And if we ever get the opportunity, I'll make sure that I buy us a nice bottle of Chianti and we can drink it together.
There we go. Absolutely.
That sounds great.
All right, brother. Well, everybody listening, if you want to learn more about what JP is doing and the rest of the team at Distributed Bio, you can either go to distributedbio.com, or you can also now go to their new website where a lot of this COVID-19 research is being routed through at www.centivax.com. That's CENTIVAX.com. The rest of the episodes of all the other DBio members are available on the Apex podcast. So just scroll right back up through your timeline there, and you will find episodes such as the life and times of a 17-year-old computational immunologist, or from Israel to immunologist with Salsin Youssef. Go ahead and give those a listen because I have a feeling that you will thoroughly enjoy them. Till next time, keep chasing that apex.